go to our folder, and I'm going to copy, that is example 2. Copy our last example into example 3. And this should give us a 1D dimension, a 1D plot. Okay, so I don't need the 1D plot, so I'm going to go ahead and delete a bunch of stuff here. But let's take a look at it real quick. Let's go ahead and delete. Do I have an X train? All right, I'm just going to go ahead and delete everything after my first model plot. So this first plot just plots the model, plots the data. That way I can still play around with it if I need it. All right, so let's go ahead and train a linear decision boundary in 2D, let's call it petal space. Right, so in our petal space, first we need to build the training set. So unlike last time, we're going to have training set of petal width and petal length. So we're going to go build the training set. X underscore train is equal to X of all of my columns. We're going to a tuple of 2, 3. And that should give me petal, PETAL, petal length and width. And then I can do Y train is equal to capital Y, where capital Y are double equal to 2. And I'm going to make this lowercase x a capital X and hit F5. There we go. I've got Y train and X train now. And so now I can go ahead and build the logistic regression model. So LOG underscore REG is equal to SK dot linear underscore model dot logistic regression. I'm going to go C is equal to, we're going to make this really big, 10 raised to the 10th power. So the higher the value of C, the less the model is regularized. So I can go ahead and just train this model now. It's going to be log underscore regression dot fit X underscore train comma Y underscore train. And now let's, all right, logistic regression is not callable. Probably because 2 brackets there. Okay, X train is not defined. You are correct. That needs to be a capital X. All right. So now I've gone and trained my model. So I need to build a continuous set of data over the 2D space so I can go ahead and plot that out. So I'm going to build the X values for the prediction over the entire petal space. That's going to be x underscore grid, comma y underscore grid is equal to np dot mesh grid np dot linspace. So on the x of that, my petal length is going to be between 2.8 and 7 centimeters, and I want, let's say, 500 points. The numbers of points that you put isn't too important, but then np dot linspace I'm going to go 0.3 to 3 to about 200. And again, the numbers of points aren't super important. However, when you make a grid, I would highly recommend that you never make it 500 by 500 because then it can become hard to figure out which side of your X and your Y. So if you have them different numbers, it helps you helps in troubleshooting. All right, so that should have created an X grid. There we go. So these are all X values going across, and then I should have a Y grid, and these should all be Y values going down. Beautiful. And then I can go ahead and go X underscore new is equal to np dot vstack X underscore grid dot reshape -1. And that's just going to put all of my grid into a single row. And I'm going to do Y underscore grid dot reshape. It's also going to put it into a single row, close all of that out, and take the transpose of it just so I can get it. There we go. Now I can get it in an X and a Y format. So a row Y is X and Y format for all of my spaces. Now I want to go ahead and predict on the vectorize format. So Y underscore predict is equal to log underscore regression dot predict, and that goes into X underscore new. So that should predict, let's hit F5, keep capital X. That should predict on all of those data points for the entire plot, right? So it gives me a prediction for the entire space, even though I don't have an actual petal there. Now, I also want to get the probability at each point. That's going to be Y underscore prob A is equal to log underscore regression dot predict underscore prob A X underscore new. Convert back to mesh grid for plotting. Seems a little cumbersome, but it's just the way that we're working it. So we're going to go ZZ underscore predict equals Y underscore predict dot reshape. So I want to put my vector now back into the shape of a grid. So I'm going to go X dot grid dot shape. And the reason I do this the long way is so I can originally get the right shape of my grid, and then I put it into a vector and I bring it back. And so all of that's kind of done in code, so I don't have to actually look at the shape of my system. So I'm going to go highlight that whole row, and now I'm going to go ZZ prob A is equal to Y prob a dot reshape x. Oh, that's not right. X grid. X underscore grid. That is not right at all. X underscore grid dot shape. Now for my ZZ probability, I only want a single part of this because it returns an aspect of the array I don't want. So I'm going to go all of my rows for column 1. Now I'm going to hit F5 and see if this runs. Okay, still running. So we're going to hope that it plots out right. So now I can go ahead and plot the petal space. Sorry, the petal space. So so it's plt.figure fig size is equal to 6.5 comma 3 plt.grid plt.grid true plt.scatter. Well, I'm not going to replot that. I should be able to just grab that from up here. So I'm looking at my petal space. So I want my second one. And I am looking at not Ceratosa. I want versicolor and Virginsia. So I want these second 2 rows. Let's hit F5 and make sure that gets, okay, there we go. So far, so good. Let's also continue our laziness streak here and copy our X and Y labels. That sounds pretty good. And then we're going to copy a legend and a tight layout. And all right, so now we've got our data plotted, right? So all of that looks pretty good. Now I need to plot my contour line. So I'm going to go right here after my data. I'm going to go plt.contourf. And I'm going to go x underscore grid, comma y underscore grid, comma zz underscore proba. So this is actually going to be my probability. So let's plot in a list here. 0.1, that's going to be my 10% probability, 0.5, and 0.9 for my probabilities. Only integers, slices, ellipses, new axes, Boolean are valid invoices, are valid indices. Oh, sorry, that needs a comma. There we go. All right, so there's a few lines. You know what? Tell you what, let's come back to that. Let's plot our actual background space first. And then we will come back to this. So let's go ahead and say contour is equal to plt.contour. And that's going to be x underscore grid, comma y underscore grid, comma. Okay, nope. I apologize. I am completely wrong. All right, don't listen to me. So let's just, okay, forget it all. All right, delete all of it. Here we go. Ready? plt dot contour F, open and close brackets, X underscore grid, comma, Y underscore grid, comma, ZZ underscore predict. Hit F5. All right, we have this wonderful plot, right? However, you'll notice that our markers are underneath our colors, so we can't see what we're going for. So let's go ahead and put comma Z order equals to 10, and that will push our scatter plot data up to the top. No, equals to 10. So 0 is going to be at the bottom and 10 is going to be at the top for our Z order. So we probably didn't need to go to 10, but we'll just shove it all the way to the top. All right. This plot works well. I just really don't like the colors. They're very strong and aggressive. So we're going to back off our colors a bit. For our contour F plot, we're going to go CMAP is equal to PASTEL, pastel with a capital P2, and that is a string. And this is purely what I think looks nice. You don't have to change your color plots, but that gives you a nice toned down background. Okay. Now what I want to do is I want to add my probabilities on top of this. So I'm going to go PLT dot contour. Well, we'll go PLT dot contour. So no F this time. And we're going to go X underscore grid, comma, Y underscore grid, comma, ZZ underscore probabilities. Prob A. I'm going to hit F5. I don't know what it'll look like, but all right. So if I hit F5, it gives me lots of different probabilities spanning this. And I can go ahead and zoom in on it, right? But maybe I don't want all of these probabilities, and I definitely want the 0.5, and none of these are actually 0.5. So I'm going to go ahead and give it a list of the probabilities I want. And I just want 10%, 50%, and 90%. No real reason other than that they look pretty good on this plot. Okay, 0.5. There we go. All right, that just gives me 3 nice distinct lines that I can see. So far, so good. I'm not even opposed to the color, but I could change the color again if I want. I could go CMAP is equal to PLT.CM.BRG. Maybe that looks a bit better, but the other color wasn't really bad. Okay, so maybe we want to add some labels to the plot, right? So if I want to add labels to the plot, first I need to create a tag here. So we're going to go contour is equal to that. That gives me something to tag. And I can go PLT.CLabel. And I can go contour so it knows which one I'm poking at. Inline equals 1, comma, font size equals 10. And that kind of gives me some inline font sizes. Unfortunately, one of the font sizes was under my legend, but if that was an issue, you could just play around with your legend size. There we go. So now I have this 0.9, 0.5, and 0.1. Just a nice clean way to show my contour lines. And then everything else looks pretty good. So that's how we can build a 2D decision boundary using logistic regression for two individual classes that we're trying to separate, right? And again, this is all within the context of regression-based classification.